Sensei, thank you very much, Sensei, for coming and join in our program.
It's my pleasure.
Okay. Sensei, you can check if you need something, you can check about share screen and something, please.
わかりました。One moment, please.
Hey.
I want to start which one? For example, this one. Can you see?
Yes, Sensei, very clear.
And how to start like this one? But
full screen, maybe.
One moment. How to start this one?
You can click full screen.
This one?
Yes, right. Okay, perfect.
Thank you. Another one moment.
Okay.
I want to change the how to Another one. Okay.
Okay, that's good.
How to change? わかりました。I understand how to operate. One moment. Oops.はいはい。はい、わかりました。I see. I am not familiar with using Zoom.
Okay.
So, please forgive me for my bad
no problem. No problem.
And the other one. Do you have any questions regarding today's presentation?
Later, Sensei, maybe after you present your material, later they will ask some question. The participant will ask some question in Q&A session.
Okay.
Hey.
Let me confirm. This is my understanding that today's participants are mainly undergraduate.
Yes, correct. Yes.
I
maybe
see.
second or maybe third year.
Okay.
So the understanding about the engineering geology is still ongoing. Okay. So maybe some question later is about basic knowledge. So please understand about that.
I see. I understand.
Hey.
And this is my understanding of another one. Totally, including Q&A, 19 minutes.
Yes, 19 minutes. Or maybe if you still have maybe 10 minutes.
No. Enough. Too much.
Okay.
Too much.
Hey, okay.
Enough.
Okay.
And, わかりました。I see. Any other one? When can I start? Just 12:30, which means that 10:30 in your country's time?
Yeah, maybe 1 minute more. We can start this webinar.
Okay. Anyway, please tell me when I should start.
Okay. Later I will give you a time to present. So first, I will open this webinar and then I will explain about the rule and about your short CV. And then after that, you can start your presentation, Sensei.
わかりました。I see. I got it.
はい。
Okay. May I ask how to pronounce your university's city name? Semarang. Which one?
Semarang.
Semarang.
Yes, Semarang.
Semarang is your home country?
Yes, my home country, right? My hometown.
You were born here?
Not really. Maybe I was born in Magelang. It's around maybe 90 kilometers from Semarang. It's near with Borobudur Temple.
Really?
Yes, very close.
I see.
It's near with Yogyakarta, actually, my hometown. So
Really?
I live in Semarang now.
I see.
Yes.
わかりました。I see.
So what about the weather in Hokkaido, Sensei?
Hokkaido is, as you know, early fall, early autumn.
Early
Yes.
autumn.
Day by day, it is getting colder.
Right.
Yes.
So the color of leaf is very beautiful right now.
Yeah, that's right. That's right. Seeing my windows, every leaves are changed from green color to yellowish or reddish.
And reddish.
Yes.
Yeah, very beautiful.
Yes, I guess you recall.
Yes, of course. That's why I miss Hokkaido and Sapporo.
Really?
Yes.
Did you have an opportunity to come once again to Sapporo? Not after graduated.
Yeah, the last one is 5 years ago, Sensei.
Oh,
I mean after graduate, yeah. So it's quite long time ago. Hopefully, next time I can go there again.
Yes, please do so. Please do so.
Thank
I'm
you.
asked Fuji Sensei or Kodama Sensei.
Hi. Hi. Thank you. So Sensei, can we start now? So I will open.
Why? Sure, why not?
Okay, thank you. Mas Reddy, mulai ya, Mas. Oke, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Good morning, my colleagues, staff, and also student of Geological Engineering Department, Diponegoro University. As we know, we already conducted 9 webinar series. And today is 10 webinar series, and we have a special guest, a special lecture about soil mechanics related to engineering geology. And for this webinar will be held around 1.5 hours, 60 minutes for speaker presentation and another 30 minutes for question and answer session. Now it's my pleasure to introduce today a speaker, Professor Kawasaki. So I will briefly introduce Professor Kawasaki. Ohayo gozaimasu, Sensei.
Ohayo gozaimasu. Good morning.
Good morning. Good day, Professor Kawasaki. How are you today? I hope today is a beautiful day to give a lecture to us. Thank you very much for joining World Class University program in Diponegoro University. And Professor Kawasaki is a professor from Hokkaido University. He is from Soil Mechanics, Sustainable Resource Engineering Division, Hokkaido University. He got his PhD from Graduate School of Engineering, Tottori University, Japan, in 1988. And he's being a professor in Hokkaido University since 2014 up to now, up to date. And his expertise is about geo-environmental engineering, environmental geotechnical engineering, rock engineering, and also engineering geology. And then regarding to his experience in publication, he has 84 documents indexed in Scopus, and citation is about 573 by 371 documents, and his age index is about 14. So it's fantastic. And I just want to give you information about his publication. Actually, it's many publication. One of example is publication with Lutfian R. Daryono. Is it correct, Sensei?
Yes, correct.
Yeah, he's still your student now. Is it correct?
Yes.
Okay. So it's about not investigation of natural beachrock in beach in Yogyakarta, like Krakal, Krukut, and etc. That's why it's very interesting. So I invite Professor Kawasaki to join us so we can learn about natural beachrock and how to understand about the beachrock and etc. So we can learn from Professor Kawasaki. And today he will speaking to us about novel beach preservation method learned from natural beachrock formation mechanism. And I believe it is a very interesting topic for us with our background a geological engineering field. So before we start, to any of you who has a question for our speaker, please kindly write down your question in chat room, or you can raise your hand and wait to be called by moderator or to you directly. So please write your question with the format, your name, institution, and question. Last but not least, please kindly turn off your microphone during this event, except you allow to turn on in by moderator or our speaker. Sebelum kita masuk ke sesi selanjutnya, saya ingin mengingatkan kepada Anda, para partisipan, kalau Anda ingin menyampaikan pertanyaan Anda, silakan untuk menulis di chat room. Kemudian kalau ingin bertanya langsung nanti bisa mengangkat tangan, kemudian nanti ditunggu dipersilakan oleh moderator. Kemudian untuk pertanyaannya, silakan untuk ditulis nama, kemudian institusi, dan juga pertanyaan. Kemudian tidak kalah penting, tolong matikan mikrofon Anda selama acara berlangsung, kecuali Anda diminta untuk menyalakan mikrofon tadi. Now, we are moved to most important session for today's event, lecture and also discussion from Professor Kawasaki. Please welcome Professor Kawasaki. The screen is yours.
Thank you very much, Dr. Naju, for your nice introduction. And good morning, everyone.
Good morning,
I'm Kawasaki. Today's my talk, Novel Beach Preservation Method, learned from new natural beach rock formation mechanism. And once again, one moment, please. Once again, brief CV. I'd like to self-introduction. I graduated, one moment please. I graduated Tokyo University, Japan, in 1988. And then I moved and worked around 10 years at the Central Research Institute of Electric Power Industry, Japan. And then after working 10 years, I moved to Osaka University, Japan, as an assistant professor for 4 years. And then moved to Hokkaido University, President University, Japan, as an associate professor, and worked by 2014. And from 2014 to today, I'm working as a full professor at Hokkaido University. And then, one moment. Before starting my today's talk, I'd like to briefly explain and introduce our university outline. So one moment, please. I want to change. One moment, please. Which one? Okay, can you see another slides?
Yes, Sensei.
Okay, thank you very much. Using these slides, I'd like to briefly explain outline of our university. And there are 4 contents. And the first one is our university outline. Second one is education and research outline. And the third one is internationalism. And the last one is our university ranking. Okay, let's move to the first topic. Regarding our university history, in 1876, our university is established as the Sapporo Agricultural College. And then 1907 becomes Tohoku Imperial University. Then, and in 1918 becomes Hokkaido Imperial University. And then, and 47 renamed to Hokkaido University. And the 2004 becomes National University Corporation, Hokkaido University, and then present up to now, 2020. Our university has 144 years. And then in near future, in 2026, we will have anniversary of 150th. Okay, next one is basic philosophies of our university. Our university have 4 basic philosophy. First one is frontier spirit. Second one is global perspectives. The third one is all around education. The last, number 4, is practical learning. And regarding the location, as you can see, our Japan consists of 4 main islands. And then our university is located in northern part of Japan, Hokkaido Island, and the city name is Sapporo. And as you can see, the Tokyo located here, it is the biggest city in Japan. Number 1 is Tokyo. Second one is Yokohama. Third one is Osaka. Fourth one, Nagoya. And the 5th largest city in Sapporo. Population is around 100 to 30 million, maybe the 50% of Indonesia. Okay? And from now on, I'd like to briefly show the beautiful nature in Sapporo and Hokkaido area. As you can see, we have a very rich green. And otherwise, in winter season, we have very heavy snowfall. But we enjoy winter season like a ski or a skate others. And can you see? We enjoyed by making a snowman. And this one is a very beautiful white illumination. And after completing the winter season, spring has come. We enjoyed rafting and others. And once again, Sapporo is located here. We have 2 campuses. Main campus is Sapporo here. Another one is Hakodate. This one is climate information in Sapporo city. Highest one is larger than 30 degrees Celsius. Lowest temperature minus lower than 10 degrees Celsius. This one is a very incredible information every winter we have around 3 or 4 meter snowfall, around 3 or 4 meters. Regarding our campus area, this green one is our university's campus. And north-south direction around 2.4 kilometer, east and west around 1.2 kilometer. And this one is located, can you see? This one is Sapporo Station. This campus is very closest. And the center, it is located center of Sapporo City. And these are dormitories. And the basic data, basic information of our university. Our university has 12 undergraduate schools and 21 graduate schools and other research institutes. And regarding the staff number, totally around 4,000 professors and officers are working. Regarding the students number, undergraduated 11,000, and graduated 6.5 thousand, and other one. And this one is already explained, so skipping. And these are the outline 12 undergraduate schools, including humanities and human science, education, law, economic science. Our faculties are located here, agriculture, and other ones. And next one is the 21st graduate schools, law, fisher sciences, environmental sciences, sciences, agriculture, and other one. Total 21 graduate schools we have. Next one is education and research. This figure, this slide shows research papers number. Major one is clinical medicine. And next one is chemistry. And so next one, plant and animal science, physics and geosciences, biology and biochemistry, and others. And we have one Nobel Prize winner. Professor Emeritus Akira Suzuki was awarded at the 2010 Nobel Prize in Chemistry for his innovative research in cross-coupling chemical reactions for the synthesis of the organic compounds. This is a photo images of Professor Emeritus Akira Suzuki. And the next topic is internationalization. This slide shows the distribution map of foreign students. Indonesia is here, and Japan is located here. And as you can see, main students are Asia. Most of the students are coming from Asia. And the other one, European country and the Africa country, and other one. And this slide shows the distribution map of counterpart university. Also, Asian major. And other ones are European country and the North American and other areas. This one is one of the English engineering education program. Shortly, we call EQ program. Over 250 courses offered in English in 30 divisions. So if you are interested in entering our university graduate school of engineering, please apply. We have some. You can use some scholarships available. And another option, if you are interested in coming to our university or other Japanese university, there are some exchangeable programs. we shortly call HUSTEP, Hokkaido University Short-Term Exchange Program, like this one. And then this slide showed another program, double degree program and cocktail program, mainly a graduate student program. In Indonesia, which one? Bogor Agricultural University, University of Indonesia, we have the double degree program we already have, but unfortunately not in your university. And next slide shows the overseas satellite office. This is Japan and also this is Indonesia. There are many satellite office, liaison office. Recently, in your country, Indonesia, it is established 2017. Maybe a Bogor Agricultural University.
Yes.
One of our satellite offices is located in the university in Indonesia. And the ranking, QS Asian University ranking is 29, and world ranking 139, and other one. And regarding our Japan's ranking, 2020 top university in Japan, Hokkaido University ranked number 6. And then regarding the other viewpoint, high education impact ranking, our university, Hokkaido University, is ranked number 1. This one, the impact ranks show how the global higher education sector is working toward the United Nations Sustainable Development Goals, shortly SDGs. So very high ranked university in the viewpoint of the impact ranks. Thank you very much. These are our beautiful campus scenery. Summer season, autumn season, now all the leaves are color from green color to yellowish or reddish color. These two are winter season. Anyway, we are enjoying 4 seasons. Okay, thank you very much. Okay.
Thank you, Sensei.
Oops, how to move? Which one? This one. Okay,
Yes.
shall we move on to the main topic?
Yes, Sensei.
One moment. Okay. Okay, today's topic. First, I'd like to explain shortly background today's talk. This sort of images shows a very beautiful scenery in Japan near Kyoto. This is a sand spit, very beautiful, one of the very beautiful sightseeing place. But coastal erosion occurred. At the time, we have to prevent this beautiful sightseeing scenery. In order to prevent coastal erosion, we have to construct breaking waters and sometimes perform the sand bypass method. But as you can see, these solutions are not cheap, expensive, and also these constructions material needs cement, Portland cement, and as you can see, production of cement released large amount of carbon dioxide, CO2 gases. So that's why we try to consider another methodology the use of an eco-friendly artificial root, not concrete material. Then we are focusing another artificial material, especially artificial beach rock as a natural beach rock. This slide shows natural beach rock located in Okinawa, Japan. Okinawa is the southernmost of Japan. Regarding the beach rock coastal sediments that have been cemented mainly by calcium carbonate within the intertidal zone. And their formative period ranges from several decades to several thousand years. So what is a merit, a strong point? First one is solidified naturally at beach, naturally formed. Second one, the solidification is continuously continued. So self-repairing ability is. And next one is a shorter formative period comparing other natural sedimentary rocks, very shorter in formation. So from now on, I'd like to briefly show your country's example of the beach rock examples. Maybe Sulaman is located around here. This one is a Java Island.
Yes.
I went maybe 2 or 3 years ago, this area. I'd like to show an example of beach rocks in Indonesia. This one, all of them beach rocks. All of them natural beach rocks. This one, naturally formed, naturally solidified beach rocks. Originally is like sediments and then hardened, cemented with time like this. Okay, this one's another beach rock, example of beach rock. Okay. This one is a pantai cracker. Pantai means in Indonesia a beach. Am I right?
Yes. Yes.
This one is a cracker beach. I went this site and investigated field investigation on natural beach rock like this. And move on the next one. This slide shows the beach rock occurrence based on a literature survey. As you can see, the red symbol, it is distributed plotted all over the world based on the literature survey done by Kawasaki. Indonesia, unfortunately, no red closed circle. But please note, this indicates that I believe there are many beach rocks, as just showed. There are no papers, no reports regarding Indonesian beach rock. And this slide shows the relationship between the latitude and the formative age period of beach rock distributed all around the world. As you can see, regarding the formative age, we varied several decades to 6 or 7 or 8,000 years. Next one is beach rock occurrence in Japan. This is Sapporo. I am now here. And today I am focusing the southernmost Okinawa area. We just shortly call Site O. And the other one, regarding Site I, shortly we just call Site I. It's Ishikawa Prefecture. The same, this red cross marker legend indicates beach rock occurrence based on literature survey. The similar figures is shown in this slide. Latitude and the formative age in Japanese Beachrock distribution. Next slide shows cement material, cement composition of Beachrock based on the literature survey. And the major cement material of Beachrock is aragonite, 20 papers. Next one is calcite. Other one is a high Mg rich calcite, and other one Mg calcite, and the other one. Anyway, main component, cement material, aragonite, calcite, and high Mg calcite in regarding the natural Beachrock cement material. This slide shows left side cement composition. And the right figure shows formation mechanism. First, I'd like to explain regarding the cement composition. Mainly, as you can see, it consists of calcium carbonate. Totally 58 papers, and 56 out of 58. Main component, cement composition is calcium carbonate. Other one is alumina, silica, and silica. And move on the right slide. This slide is the formation mechanisms of Beachrock. Main formation mechanism is, as you can see, seawater evaporation and or biological processes. Next one is precipitation from fresh water. Next one is seawater, fresh and freshwater mixing. And CO2 gas degassing and other one. So main reason, formation mechanism is seawater evaporation and biological processes. Today's my talk is mainly focusing on this one, biological process. Okay, shall we move? Today's first topic, formation mechanism of Japanese Beachrock, especially Okinawa area and Ishikawa area. And the first one is the objective. In that study, we conducted several tests to understand the formation mechanisms of Beachrocks to aid in our ability to make artificial Beachrock. Once again, study sites, Japan, and once again, study sites, Okinawa area, Ishikawa area, and just today, I just shortly call site O Beachrock. And other one is a site I, mainly focusing on only two sites, site O and site I. And the left side indicates site O's Beachrock, and the right side indicates the Beachrock, natural Beachrock located in site I. And as you can see, both sides in the distributed two different types of Beachrock. First one is a varied Beachrock. Varied Beachrock is beneath the displays, and the other one is outcropped exposed Beachrock. So there are two different types of Beachrock. Similar tendency can be seen in the other side I. Can you see this area? This area you can see the exposed Beachrock is here, and the lower portion, varied Beachrock is located under the sun. And from now on, I'd like to explain what we did regarding testing method. We selected different three testing methods. Mainly, we want to focusing. We want to obtain three different types of property. First one is a mechanical property. We want to know Beachrock mechanical property. Second one is a chemical property of Beachrock. Third one is a biological property of Beachrock. And regarding the mechanical properties, we conducted needle penetration test. Regarding the chemical property, we conducted elemental analysis, mineral analysis, and water analysis. And the last biological property, we conducted microbial population counting. And later I would like to shortly explain Urease activity test. Then due to time limitation, I mainly focusing on these three testing results: needle penetration test, elemental analysis, and the Urease activity test. And the first one, what is a needle penetration test? This is a schema diagram, images, photo images of needle penetration equipment. Can you see the top? Needle is mounted here. Using this equipment, we estimated the hardness or strength of rock material, soil material. This figure indicates the relationship between unconfined compressive strength, UCS, or shortly UCS or QU. And the vertical, horizontal axis means the parameter NP. This one is obtained by conducting needle penetration test, needle penetration test parameter. When conducted needle penetration test, we can obtain this parameter NP. For example, if the NP equal to 10, using this chart, we can estimate it. The materials UCS and compressive strength might be around 40 kilonewton per square meter. Like this, we estimated using this equipment. Regarding how to identify the cement material, we choose different three methodology equipments. First one is SEM, scanning electron microscope. Next one is shortly we call EDX. It stands for energy dispersive X-ray spectroscopy. Sometimes EDX is called EDS because EDS. Or in this my presentation, EDX we just use. The last one is XRD, X-ray diffraction, shortly called XRD. Please remember, sometimes we use this short keyword, SEM, EDX, and XRD. This one is a microscope. This one is equipment. When we want to identify the element of material. This one parameter, when we want to identify the types of crystals, And next one is a resultant discussion. First one is a mechanical property by needle penetration test. Blue one, as you can see, shows site OS data. Reddish color indicates site ice data. Comparing these to the sites, as you can see, horizontal axis means the unconfined compressive strength, QU, megapascal. As you can see, comparing both two sites, site O's UCS, unconfined compressive strength, is larger than other site I. And in detail, comparing the exposed Beachrock and the buried Beachrock, exposed Beachrock and buried Beachrock for both sites. Exposed Beachrock's UCS is larger than that of buried Beachrock. Same tendency can be seen in site I. Exposed Beachrock in UCS is higher than that of buried Beachrock. Next one is XRD results about the cyto samples. This one shows the exposed Beachrock's elemental analysis data. Next one is the buried Beachrock's data. The last one is the original sandy material. As you can see, this one is a mother material of Beachrock sample, Beachrock. So all of them are similar carbonates, right? Can you understand? Blue one is magnesium high calcite. Reddish triangle indicates aragonite, and the blue cross means quartz. Similar, almost all of them similar. Next one is regarding the process of consideration about the Beachrock formation mechanism. First one is the analysis results, Beachrock cement by SEM, EDX, and XRD. And this one is the results on SEM images, Beachrock in Okinawa, Japan. This one is images from other papers. As you can see, similar shape of the crystals can be seen. This one is explained as a high Mg calcite. And this figure shows the EDX results. As you can see, the horizontal axis means elemental percentage. Blue one is C carbon, and the next one is oxygen, and the green one is magnesium and calcium. Very close relationship. And this one is common sense in the field of geology or engineering geology. High Mg calcite, shortly it is called HMC, is a polymorph of calcium carbonate containing more than 1.2 weight percentage magnesium carbonate. So one of the results is this. This main cement material was high Mg calcite. And next one, literature survey results regarding the high Mg calcite. Mg over calcium molar ratio, how to control, is the solution is larger than 4. It is easy to precipitate it, high Mg calcite. And also malate and citrate, these are one of the examples for the organic matter. When these are included, they favor the formation of high Mg calcite. Based on our water analysis, this one is our results. Our results shows Mg over calcium molar is indicated as 6.3, so which means larger than 4. And also unconfined sediments near Beachrock contain sea agar shells and corals and bacteria. So these organic matters might give malate and citrate. So one of the result is like this. When seawater evaporates in the above condition, high Mg calcite would be precipitated. And the next one is Urease activity test for bacteria in sun near Beachrock. This one is sun near Beachrock. Beachrock is here, and obtain the sun. Then using marine agar cultivation for marine bacteria, we evaluated which one is urease activity, ureolytic bacteria, which one is not ureolytic bacteria. And these chemical reactions indicates urea hydrolysis. This one is urea. And urea hydrolysis naturally occurred from the left side to right side. And as you can see, urea after when urea hydrolysis occurred, urea changed from the ammonium ion and OH minus and CO2. So from left side and the right side, when an enzyme called urease is existed, urea hydrolysis accelerated very quickly. So when existing calcium ion in the solutions, calcium carbonate precipitated suddenly, naturally. This ball shows originally each ball is filled with distilled water and urea and cradle red. These three components, each ball include. And cradle red is one of the typical pH indicator. When medium range in pH, it indicates around yellowish color. If pH increase, changed from neutral range to basic range or alkaline range, it changed from yellowish to reddish, like this one. So as you can see, these balls are keeping the neutral range in pH, but pinkish color indicates alkaline or basic in pH. Yes, okay. So when adding each bacteria or one of them, each ball, one after another, if change the color from yellowish to pinkish, this bacteria is designated as ureolytic bacteria. And the radioactivity tests like this one, and we used marine culture. Then just one after another put in each bacterium in the water. Then observe whether the color change or not. And this one is our laboratory's evaluation results, formation mechanism of Beachrock site and Okinawa. This one's a land. This one is a seawater. Then varied Beachrock is located here, and exposed Beachrock is located here. And this area is consists of coral sand, not silica sand. Then the bacteria, ureolytic bacteria is existing everywhere. And organic matter also existing everywhere. Then urea is existing everywhere, but in this case, coming from the land. Then calcium ion is coming from the sand, because coral sand mainly consists of calcium carbonate. So this sand is rich in calcium ion, so easy to obtain calcium ion. Then not only coral sand, but also the seawater is rich in calcium ion and also magnesium ion. So biological process urea hydrolysis occurred around here. So naturally varied Beachrock formed at this area. And then regarding the exposed Beachrock, seawater is up and down occurred, tidal range change. So when seawater evaporated, calcium carbonate precipitated. Once again, comparison of cement composition and the formation mechanism of Beachrock, 58 sites in the world. And the first one, cement composition, site O, mainly calcium carbonate compounds. And the site I, today, due to time limitation, I skipped, but this site mainly consists of alumina, silica compounds. And formation mechanism, regarding formation mechanism, site O is considered evaluated as a seawater evaporation and or biological process. And site I, regarding site I, mainly formed freshwater mixing. This one is a conclusion, both site O, Okinawa site, unconfined compressive strength around 28 megapascal, and the main cement material is high Mg calcite, and the formation mechanism is a bacterial urease activity and seawater evaporation. On the other hand, site I, smaller than site O, 3 megapascal in unconfined compressive strength, and the main component, main cement material, alumina and silica. And the formation mechanism is mainly a mixing of seawater and spring water. Next one is the solidification test. This one is already I explained. Then this one is skipped. This figure shows what is the MICP. MICP stands for microbially-induced carbonate precipitation. Okay, microbial-induced carbonate precipitation process. 1, 2, 3, 4. I'd like to briefly explain shortly. This is the bacterium, a bacterium. As you can see, this area, urea hydrolysis occurred like these chemical reactions due to the bacteria, because this bacterium has urease, an enzyme. And also next one, calcium ion, when calcium ion is existing around bacterium, usually the bacterium has a negative charge on the skin, minus charge, so easy to attract calcium ion. This is calcium ion is positive, so positive ion is coming and attached and located surrounding the bacterium. And little by little, calcium carbonate precipitated around here, little by little. And finally, this bacterium is covered with calcium carbonate precipitated. This is a schematic diagram, MICP process by bacterium. And this one is example of, excuse me, how to say, example of moving results. Can you see the moving small bacterium? This one is precipitated calcium carbonate, already precipitated calcium carbonate. And there are many, many moving small spherical bacteria. Then little by little, calcium carbonate is precipitated like this. Okay. The next one, how to make artificial rock modeled by the Beachrock. We conducted, which one? We conducted a solidification test using a syringe. There are two objectives. First one is to obtain the specimen whose unconfined compressive strength UCS is more than several megapascal. Next one, to consider the effects of test conditions on UCS. Methodology is skipping bacterium cultivation, like this one shaking, then poured from the top. And this one is the methodology. First prepared consolidation syringe, including bacterium. This syringe is filled with coral sand. Then after outlet solutions, we measured calcium ions and the pH. After conducting a syringe solidification test, we obtained the solidified samples. Then conduct needle penetration test here in order to evaluate it, the estimated UCS, estimated unconfined compressive strength. Methodology, each one, around 40 gram dry sand, coral sand is filled. Next one, each syringe, we poured around 60 milliliter solution, we added. And then bacteria is isolated from Okinawa area, local area. This one is no need to remember. This one is a main component, solidification, solution of consolidation, including this material. And solution as a consolidation injected from the top and drain several intervals. Then after 2 weeks, after 14 days curing, we measured unconfined compressive strength and the elemental composition and the microbial population using this one. This one is a testing case and standard condition and the standard temperature, curing temperature, we fix 30 degrees Celsius, then injecting interval 1 day, adding of sodium malate consolidation solutions 0. And then first one is syringe test, 2 weeks curing, around diameter is 2.5 centimeter in diameter. Height is around 7 centimeter. The curing temperature we varied, not only 30 degrees Celsius, other one, 25 and 35. And also injected interval also, not only 1 day, but also 0.5 and 2 day. And adding organic matter, not only 0, 1 or 2, 5 grams per liter. And the more larger size we want to we conducted. This one is a 2.5 centimeter, the other one is a 5 centimeter, 2 times larger than the syringe. We just call column test. Today we just show these red squared results. This one is a typical results, curing temperature effect. Curing temperature 25, 30, and 35, and the estimated UCS obtained from needle penetration test. As you can see, UCS becomes larger with curing temperature. Okay, move to another one. Adding effect, organic matter, sodium malate. This one is SEM images. Sodium malate 0, no adding sodium malate. On the other hand, right images indicates the example in the case of sodium malate 5 gram per liter. Then this one shows EDX results. As you can see, there are no magnesium. Magnesium ion is not included in this case. On the other hand, when adding the malate, sodium malate, 0.6 weight percentage included. This one is the difference between left side and right side. So cement material in this left side, calcium carbonate is aragonite. On the other hand, right side cement material, high Mg calcite due to adding organic matter, in this case, sodium malate. This one is the temporal variation in UCS microbial population. This one, vertical axis indicates UCS, and the horizontal axis means curing day. Blue line indicates UCS change with time. And as you can see, UCS increase with time. And regarding the population of bacteria, it is obtained, top middle bottom, which means the top middle bottom. We obtain samples and counted population of bacteria. Overall, no change. Little bit decrease, but overall no change. This one is the population bacteria. And this one is the conclusions, the second topic. We just explained using a syringe test and a column test using a bacteria whose name is a Paralobacter species, isolated from Okinawa area. And next typical results obtained. Curing temperature is UCS were larger at warmer conditions. And the next content, sodium malate, organic matter, no additive case. Cement material was aragonite. On the other hand, no when adding, cement material changed with aragonite to high Mg calcite. The last one, model tests. First one is objectives. This model test conducted for obtaining the uniformly strength soil sample. And strength characters observed. This one is the experiment model test conditions. Only 2 cases conducted. Case number 1, this one, temperature fixed, both testing case 25. And the injection intervals 1 day. And the curing time, number 1, 14 days. Number 2, case number 2, 3 weeks, 21. And the population same, initial bacteria is 13 gram. Re-injecting bacteria, number 1, no adding. And number 2, once again added after 7 days later. And the height sample is same, and the same sand material. This one is a schematic model test diagram. This area indicated the sand ground model test model. And the box, clear, transparent box we prepared and filled sand, natural sand. And the height is 9 centimeter. And the lowest basement is we seated filter paper. Then added consolidation solution and bacteria solution from the top and the outlets. This was the results day 1, day 7, day 14. Totally 2 weeks we continuously conducted. This one is chemical concentrations composition. Please, no need to remember, please ignore. Important thing regarding this one is little by little, color change is changed. Little whitish color. Okay. This one's a case 2. As you can see, day 1, 7 days later, 14, 21st, little by little, the color of sand material change, whitish color. And this one is the pH and the calcium ions change with time. And the testing case 1, the testing 2 is indicated like this. And the testing case is blue one. It in pH decrease with time. But when 9 days later, it is increased, once again increased, because we added bacteria, re-injecting bacteria here. Then at a little by little decrease. Then when adding bacteria, it increase. Pinkish color testing case, no adding re-injection occurred. So pH decreased with time. Calcium ion also the similar tendency. Pinkish color, or this is pinkish one, is increased with time. On the other hand, blue one, test case once increased with time, but after re-injected, decrease. Then increase and after re-injected, decrease. Alternately, it change. This one shows color observation results. We use colorimeter or spectrometer like a digital camera, like a digital camera. We measured color change at this point. Number 1, this plane, this side, 1, 2, 3, 4. This is the bottom side and side wall. These two indicates the color change. The horizontal axis means the location, like this point, some measurement point. And the vertical axis means delta L star. Delta L star is the parameter which indicates the black and white. If this value increase, the material's color becomes whitish, little whitish. As you can see, both testing case. Reddish one is original starting point. Then with time goes by, delta L star increase with time. Do you understand? This one is a starting point. And little by little, day 1, day 3, day 11, day 21st, the overall, the tendency is increased in delta L star. So little by little, the color changes whitish color. Okay. Next one, after cemented samples, solidified samples, we cored and obtained core samples by different direction. First one is a horizontally cored. We obtain horizontally cored samples. Other one is the vertically cored samples. We obtain different directions cored samples. Testing case 1, testing case 2 also, both. This slide indicates testing case 1 and testing case 2 and estimated UCS, and depth from the top. This is that obtained data by needle penetration test. As you can see, the estimated UCS decrease with depth from the top. Schematically illustrated, estimated UCS decrease. On the other hand, using horizontally cored samples case in testing case 2, different tendency can be seen. As you can see, almost similar, same value in estimated UCS obtained in these 3 samples. Then we evaluated by XRD test, XRD observation. Left side indicates vertically cored sample case, and the right side horizontally cored samples. On the left side, vertical cored samples, as I said, this sand consists of silica. So mainly consists of more than 90% in silica top side. On the other hand, bottom also mainly consists of silica. On the other hand, regarding the percentage, containing percentage of calcium carbonate, and the top portion, in this case, 8.5%. On the other hand, the lower portion, 3.5. So top portion is higher in calcium carbonate percentage. On the other hand, regarding the horizontal cored samples, percentage in silica almost same. And also calcium carbonate component almost same component, the left side. Well, left side means the vertical cored samples. So uniformly cemented in precipitated calcium carbonate. Okay. And another viewpoint I want to explain using X-ray CT results. This one is an image data on in top section and the middle section and the bottom section. Then whitish portion indicates high density portion. High density material is located. For example, comparing the top portion, top section, and the bottom section, as you can, which is larger in whitish area. Maybe left side, top portion is very much whiter than right side. So much calcium carbonate precipitated in top area, comparing the bottom area. calcium carbonate precipitate decrease, and the UCS decrease. And this one, we try to solidify this area. This one is consists of mainly silica sand. And not only this area, but also bacteria is existing. Not only the sandy material in sandy material, but also this water solution area. So not only calcium carbonate precipitated not only inside of the sandy material, but also these solutions. So little by little, precipitated calcium carbonate is penetrated from the top of the surface. That's why UCS, estimated UCS is higher than lower portion. This figure indicates the comparison of the relationship between UCS and the calcium carbonate content with various studies. And this one is our laboratory's results, estimated UCS and calcium carbonate content. And this right figure indicates the vertical axis means estimated UCS and content of calcium carbonate precipitated. Let's see the blue one and the reddish one. There is a small gap, as you can see. There is a small gap. We have to discuss. We have to evaluate in future. I think this is future work. So shall we conclude today's presentation? We focusing mainly bacterium concentration and injected or re-injected bacteria and the particle size and the injection interval and the concentration of the cementation media and the curing time and the temperature. Some of the content we skipped due to time limitation, but we discussed in our laboratory. Up to now, we obtained the data more than 3 megapascal estimated UCS and more than 10 megapascal, changing the concentration of the cementation media. And when re-injected bacteria solution, we could obtain more higher strength samples in UCS. Okay, it's almost time to stop. Thank you very much for your attention. Terima kasih.
Hey, Sensei, thank you very much, Sensei. It's very interesting presentation. So before we move to Q&A session, I would like to remind to our respected participants to fill link of attendance in chat. And sebelum kita mulai acara tanya jawab, saya mengingatkan kepada para partisipan, ketika nanti ada link untuk form kehadiran, silakan untuk diisi. And now we will continue with the Q&A session. We have maybe only 20 minutes for question and answer. So we have, Sensei, we have many questions here. Maybe, yeah, most of students ask a question, but I believe time is limited.
Okay.
So I will pick up some question. First yes. Question from ex-Saudi, from Diponegoro University. Ohio, Professor. I want to ask you about how the process of Beachrock self-repairing, how Beachrock repair itself. And second question, can corals that are already dead be called Beachrock too? Thank you.
Oh, thank you very much for asking. I cannot catch the second one. So first, I'd like to explain the first one. Today, I explain this one. This one is our evaluation results, how Beachrock formed naturally.
Mhm.
So this is, as I said many times, it is naturally occurred.
Mm.
But fundamentally, we cannot wait long time because the natural Beachrock formed, which need a long time, several decades, years, or several hundred years, or several thousand years. So we have to evaluate it. We have to accelerate it by adding much bacterium or much high concentration of calcium ion, and also high concentration of urea. Then urea hydrolysis, as I said, is occurred here. So little by little, once the coral sand or silica sand solidified up to several megapascal or several kilopascal, I don't know. Anyway, hardened, but the hardened beach rock is occurred in buried ocean. Little by little, the strength increased due to biological urealysis. And also how to conduct like this. This is the first original, this is the first step, how the beach rock, natural beach rock occurred in every year. Next one, after hardened, as you know, tidal range changed with time, maybe 2 times. So after hardened, beach rock, little by little, which whose strength increase due to seawater evaporation. So repairing occurred, both methodology effects. One is urea hydrolysis due to bacterium, and the other one is seawater evaporation. Okay, that's all. It's okay?
Hi, Cece. Thank you very much for your answer to the question.
Second one?
Second one, about the corals.
Corals.
Yes.
Yes,
That
this
if
one.
it's already dead, can we call beach rock also? If already dead, not live,
Yes.
but dead. It's called beach rock also?
Yes, fundamentally, the beach rock, natural beach rock consists of coral sand. Coral is already dead. Fragile one.
Already dead.
Yes.
Hi.
Okay.
Hi, Sensei. Another one question from Alvin. Based on XRD site O sample result, where the most composition is aragonite, and how is the process formed? Aragonite, Sensei. Composition is aragonite. I'm sorry, Sensei, your voice is not clear. I'm sorry, I cannot hear your voice. Sensei, I'm so sorry. I cannot hear your voice. Maybe your microphone, the cable is plugged off or something. Not yet, Sensei. No, not yet, Sensei. Can you check the cable or something? Or maybe you can plug off the cable and then you can say directly to your laptop. Not yet.
My voice?
Yes, your voice now. I can hear your voice.
Can you hear?
Yes, very clear now.
Oh, okay. I want to use my PC's microphone. As I said, when including a magnesium ion, like this one, it is said usually calcite, not aragonite, precipitated easily. But on the other hand, if including a magnesium ion, easy to precipitate aragonite. I don't know the reason why. I am not a mineralogist. I am not a geologist. It is common sense. So that is the difference between aragonite precipitation and calcite precipitation, depending on the concentration or including or not including the magnesium ion, mainly.
Yeah.
Okay.
Okay. Thank you, Sensei. Another question from Titis Mentari. Please, you can unmute your microphone and then you can ask your question.
Okay, thank you for the chance. Can you hear my voice clearly?
Yes. Please.
Okay, and there's several questions that I want to ask you, Sensei. So the first one is, can we use another bacteria in the strange solidification test than Fara root bacteria? And then the second one is, is there any difference between the artificial beach rock with the original beach rock? And the third one, and also the last one.
Excuse me, one after another, I want to answer.
Okay.
Please, first one, let me confirm once again. Your question is that, do I have another testing case using a different bacteria?
Yes.
Yes, I have many different types of bacteria we used. Not only sea bacteria, but also land bacteria. Today, only I'm focusing on sea bacteria. Fundamentally, ureotic bacteria, which has the possibility, ability to form rock, like a beach rock, artificial beach rock, is existing everywhere. Is okay? That's all. Is it okay?
Yes.
And may I ask, please, second one, please?
Okay, the second one is, what is the difference between the artificial beach rock with the original beach rock? I mean, it's like the physical difference?
Oh, thank you very much. Fundamentally, the component is almost same, but structure is quite different. Because regarding the natural beach rock, it forms using a long time. So little by little, crystals form, and little by little condense and cemented. On the other hand, in today's our presentation, this methodology accelerated solidification of artificial beach rock. So precipitated crystals is not stable. So I guess the strength is a little bit smaller in especially the artificial one. Third one, please.
Okay. I want to ask the last question. So, is the beach rock affected by dissolution process just like limestones and the other stone with high carbonates?
Very good questions, but I don't know the clear answer. But as you know, the beach rock is located near the shoreline and near sea. So as you know, the seawater is rich in calcium ion and the magnesium ion. So even though when the beach rock, natural beach rock is located in near sea beach, there's no problem for dissolving or erosion problem. Is that okay?
Yes, thank you, Sensei, for the answer.
It's my pleasure.
Yes, Sensei, it's almost 1.5 hours for our webinar. So I think this is the end of this session. I'm so sorry for the participant. Since actually many questions, maybe more than 50 questions from the participants. So if you don't mind, I will send to your email only for check about the question, and maybe some question is not the answer from your presentation. Please, maybe if you have time, you can answer the question. Thank you very much, Sensei.
It's my pleasure. Thank you very much for attending.
Yeah. Yes, okay, Sensei, thank you very much. Maybe I just want to give a conclusion. Professor Kawasaki already explained about the beach rock, which is an eco-friendly artificial rock. And then there are many advantages of beach rock, such as solidified naturally at beach and self-repairing ability, shorter formative period than other sedimentary rock. And Sensei also explained about how the formation mechanism of beach rock, and you already got the point. And Sensei also explained about the process of creating artificial rock. He already conducted about the solidification test on coral sand using local bacteria. So I think that's all is already explained by Sensei, but unfortunately, time is limited, and now we come to the end of session. Sensei, on behalf of World Class University Program Committee, I would like to say thank you very much for your time, for your valuable sharing knowledge and information. And we also thank you very much for all participants, from your active participation until the end of this session. So we do hope that all the material that explained by Sensei enhance our knowledge about engineering geology application. Thank you very much, Sensei. Hopefully,
it's my pleasure.
Hopefully this is not the end, but we can do it in the near future, or maybe the next year.
Why not?
Okay, thank you, Sensei. Thank you very much. And this is the all of session already done. So please now Sensei, it is for photo session.
Photo session.
Yes. So please for all participants turn on your camera so we can take your picture together with Sensei.
Okay, I see.
Hai. Mas Reddy atau Mas Sauki nanti tolong ambil foto ya. Please all participants turn on your camera so we can take a picture. Just 1 minute. Okay, please. Okay. Sensei, I'm so sorry. Could
Why?
you turn off your screen, share screen so we can take a picture for all participants?
Can you stop?
Yes, stop. Share screen.
Thank you very much.
Yes. Only
Thank you
turn
very
on the
much.
share screen. Yes.
Terima
Sensei.
kasih.
Yes, thank you very much. Terima kasih, Sensei. Just turn off your share screen, and then we can take photo together. Yes, like this. Okay, I think Sensei already turned off. Okay, please take a picture together. Sudah, Mas Reddy? Atau Mas Sauki?
Kalau saya baru Pak, baru di tag sekarang Pak.
Saya sudah Pak.
Oke, baik. Okay, thank you very much. We still have one webinar in the next Friday with the Professor Yasufuku from Kyushu University. And then thank you very much for all the participants and committee. See you all again next Friday. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Sugi.
Sensei. Yeah. Thank you very much, Sensei.
It's my pleasure.
Yeah, thank you very much. Okay. See you again.
Shall we close?
Yes, thank you very much, Sensei. You can leave now. Thank you very
See
much.
you somewhere.
Selamat ya. Terima kasih.
Terima kasih.
Hai. Baik, untuk acara hari ini sudah selesai. Terima kasih atas partisipasi semuanya. Untuk pertanyaan yang belum terjawab, akan saya sampaikan kepada Sensei, akan saya kirim via email. Sehingga nanti kalau ada jawaban, nanti akan saya share di grupnya untuk ke format untuk di-share kepada Anda semua. Terima kasih.
Ini sudah bisa di stop recording ya Pak Najib ya?
Bisa Mas. Sudah selesai, nggak apa-apa.
Thank you Syauki, sudah di backup tadi sempat mati listrik.
Sip.
Ya, perlu ada backup ya Mas ya.
Iya Pak.
Siap-siap kalau terjadi seperti itu.
Iya, sip.
Izin live dulu Pak Najib.
Boleh, silakan Mas. Saya juga live. Terima kasih semuanya.
Pak Najib ini saya.
Pak.
Baik, bisa di turn off kan.